Hello friends, in last lecture we have studied the Zener diode. In this lecture we are going to discuss tunnel diode. What is meant by tunnel diode? Construction of tunnel diode, history of tunnel diode, and which material are used to manufacture the tunnel diode and its application. First of all, the history of tunnel diode. Tunnel diode was invented by 1958 by Leo Iski. Lewis observed that if the semiconductor diode is heavily doped with impurity, it will be exhibit a negative resistance. In 1973, Lewis received the Nobel Prize in physics for the discovering uh, the electronic tunnel effect used in the diode. But in semiconductor diode or in PN junction diode, whatever the semiconductor material is used in heavily doped, that the doping level is impurity, near some negative resistance is not there. So this negative resistance is not there in that semiconductor diode. Uh, to overcome this topic, the Lewis was invented. This tunnel diode. Why they invented tunnel diode? What is the requirement of tunnel diode? Necessity of tunnel diode. The require is in a general purpose diode or PN junction diode or Zener diode. Switching time is more required. Switching time is more to switch the condition. To overcome this drawback, the tunnel diode is invented. In tunnel diode, require very less switching speed. It's very fast response. And in fusion junction diode also or general diode also, the response of diode is very more means more time required to respond the diode, but tunnel diode is a very fast response. The response of tunnel diode is very fast. And another advantages over the diode is that a single device can be used for many purposes, but in PN junction diode, only one device is used for only one diode. But here, a single diode can be used for many purposes like oscillator, logic memory, storage devices, memory, all that. And so that's why maximum time tunnel diode is used for tuning purpose, oscillator or AM receiver, FM receiver, to tune the frequency. For that, the tunnel diode is required. These are the symbols of tunnel diode in various steps. Like A is the tunnel diode B diagram. See here. This is the different symbol of tunnel diode. This is the symbolic and tunnel diagram or outer look of tunnel diode. This 173 is the number of that tunnel diode. The same like anode and cathode terminal. These are the construction of tunnel diode. Simply construction is some modification is there. Lead and lead both side. This upper side is the cathode terminal and ground down below side is the anode terminal. Here some another effect is that tin dot, and on a semiconductor material is gallium arsenide and a silicon germanium lead, and a ceramic body is there outer side of that ceramic diode, because it's protection of hazardous effect like atmospheric effect. This is the screen tin dot. cover is connected to that, and all these things in here. Construction of tunnel diode. See here, which material are used for to construct the tunnel diode? Maximum time, the gallium arsenide, gallium cerium, and gallium arsenide material are used for that. Maximum times the semiconductor gallium arsenide material are used. The operation of tunnel diode is that the tunnel diode is also known as Iski diode, which is named by after invented by Leo Iski for his work on the tunneling effect. The operation of tunnel diode is depends on the quantum mechanism principle known as tuning. Quantum mechanism means we adjust the knob or the tune that. In electronic, the tuning means a direct flow of electrons across the small doping region. Tuning means, what is the tuning? If your question comes in your mind, tuning means we adjust the resistance, negative resistance, tau. The makes direct flow of current across the depletion region from n side conductor band into p side valence band electron. We adjust only the region of depletion region, means the flow of electron from n side conduction band into p side conduction band. This is the tuning of effect. This is the tunnel effect. Here see the diagram number 1. This is the ordinary p-n junction diode energy flow diagram. If these are the saturated electron is here gather in ground floor, if they receive energy from others, then they or jump the electron and go ahead to pass the barrier to jump. This is the electromagnetic. See here, the electron with energy greater than the barrier potential can pass over the barrier. If the electron energy is less than the potential barrier, they cannot be passed. See here in first diagram. This is the ordinary p-n junction diode, and in tunnel diode here, the electrons tunneling through the barrier, means the barrier is there, but it is the tuning. It's very less electron required to pass the very less energy required to pass the barrier of electron. This is the tunnel diode. This is the diagrammatical effect of tunneling diode. And this is the operation of tunnel diode. This is the covalence band, and lower the valence band. This is the n-type material. Okay, the red dot showing the electrons and p dots green dot showing the protons. And this is the energy in the valence band. If the electron is proton get energy from in other external devices like sun or power supply, then proton jump from valence band to covalence band, and they gather in covalence band and lose his energy, and they come back to the valence band. These are the n type material, and p type also same. They gather in covalence band. Protons who gather in valence band, if they get external energy from external source, then they jump and lose his energy and come back to the valence band, valence band. In p type material same like this is the energy we already see in energy band. So without forward bias current and forward bias, here the depletion layer, a n side and p side. This is one band, and these are the electrons, and these are here no forwarded bias, because there is no energy, electric energy between from this. So this they cannot be flow, and they not forwarded to deflection region to proton and another region with small biasing current. Here is a very small biasing current, because here the full tuning and small forward bias. Here the tuning is there, it is a tune. Then the electron flow from negative type to for valence band, n side to p side, by electrons and protons is recombine this attract from this energy flow, and recombine and flow of electron is full tuning is a small operation. These are the operational diagram of forward voltage of tunal diode. This is the forward current, y axis showing the forward current and x axis showing the forward voltage. And here are the point one if is there. So if the electron, the voltage is increased, current also increase. At the break point, the current is cannot be increased if and come to the back negative resistance of the downside. And valence point is here. These are the valence point and covalence covalence current. Here is showing here 0 is the covalence, and these are the forward resistance. A is the peak point of voltage and current is here. The maximum peak voltage and peak current is showing. After that they come to the reverse, means after suddenly cannot be increased in the current. It's the bell type showing this. The main advantages of tunnel diode is that the advantages of tunnel diode, his lifetime is a very long as compared to the PN junction diode. The speed of operation is also high, because it's a very switching speed is very fast as compared to the general diode and PN junction diode. And at the time of operation they it cannot be make a noise, or it's a very low noise. And the another advantage is also is the power consumption is low, power consumption is there. In the tunnel diode is required very less power to operate on that. These are the advantages. Some of the disadvantages of tunnel diode is that the tunnel diode cannot be fabricated in large number of quantity if with the if because the material and all other the cost of that manufacturing is very less, more, and application is very less. That's why it cannot be fabricated in the large number of. Being two terminal device, the input and output are cannot be isolated from one another. These are the disadvantages of tunnel diode. And some of the application of tunnel diode here. The tunnel diode are used as a logic memory storage device. I already told you at the beginning of this lecture. The tunnel diode can be used in memory storage devices for logic memory. And tunnel diode, another application of tunnel diode are the tunnel diode are used in relaxation oscillator circuit, because in oscillator circuit we can use the tunnel diode for tuning the oscillator, adjust the crystal frequency for that. And the tunnel diode is used in ultra high speed switching. It's also used in ultra high speed switching, because the switching time is very less, it's very fast to operate on that. So that's why it is used in ultra high speed switching. And tunnel diode are used in tunnel diode are used in FM receiver or AM receiver, because to tune the frequency where they got strong frequency, then they receive the signal for that. We can observe in practical the tunnel diode in FM receiver, in analog communications subject FM receiver and AM receiver. At that time we see the FM receiver, and that the tunnel diode how it's work by the practically. So thank you for the tunnel diode. Whatever the use of that tunnel diode, we see how it's manufactured is also see. And if any question, please comment on my video below video. Now going to the avalanche photodiode. Avalanche photodiode, how it's work, and then how it is introduced to performance and all other. The introduction in part, the performance of avalanche photodiode depends upon the efficiency. It converts the high energy into electrical signal. It converts. What is meant by photodiode? Anyone know? Photodiode is the effect of photodiode is that if the light energy uh, is converted into electrical energy, but how it's, if we know the photocell, everybody, yeah, photocell is that if is the means if the light energy is spreading on that photoelectric material, the electric material is convert, it's the reduce the decrease the resistance and increase the conductance. In that is also photodiode is also the semiconductor material, same. So it's that if the energy, light energy or any other energies or heat is comes from outer side on the surface of that photo material, they convert the light energy into electrical. See here the principle of design operation, and that designed to operate in reverse bias condition. The main difference is that it designed to operate the reverse bias condition, the photoelectric effect. See here the light incident on photons on material. The material is eject the electron, and they pass the energy. See here the um, principle of photoelectric photo avalanche photodiode. Here the construction diagram. The avalanche, the high gain due to avalanche, the multiplication effect increase the noise, and silicon has gain but low noise, high gain but low noise. The selenium arsenide gallium acid, and that often is used for photodiode. Here the N material and P material is showing here. Deflection range is more if the material is electric field and all others. Here the P and N junction material is combined. I show here because P is connected to negative terminal and N is connected to positive because it operates on a reverse bias. If the energy is there, the deflection region is increased, and small fluctuation is there. The small amount of current is flow in this circuit is shown here. The avalanche photodiode high resistivity of p doped layer increase the electric field across the observing region. The high energy electron hole pairs ionize the other side to multiply the current and leads to greater resistivity. Single current is equal to this is the construction diagram, the AB structure and field distribution is 1986 here. These are the construction diagram of equivalent circuit for that P junction. So these are the transition time, carrier transition time equation. Here the transist time is function of deflection width and carrier drift velocity. The TD is the transition time, is deflection range is that phi W upon VD. W is the width of deflection layer and VD is the velocity of drift velocity of that to calculate the transient time. Transient time is the response of photo avalanche photodiode. How much time required to respond to that is the requirement. These are the equation for that. And here the deflection capacitor is that the PN junction, P type and N type. material is showing here. This for the capacitance here. The capacitor must be minimized for high sensitivity, low noise, and for high speed operation. The capacitor must the depletion layer is very less for the minimized by using the smallest light collecting area consistent with effect of collection of the incident light. The minimize by putting low doped I region between the P and N doping region to increase the W and deflection width. W can be increased until field required to fully depleted cause excessive dark current or carrier. Here the for the F or formally independent junction C is equal to A by 2 came from where the epsilon is the permittivity constant and Q is the electron charge and Nd is the active doping density and V is the applied voltage and V is the build potential and H is the junction area. So the capacitors, to calculate the capacitance, is A by 2 means the A is the junction area divided by 2 into 2 epsilon is the epsilon is the permittivity constant and Q is the charge and phi 0 is the applied voltage and V is the build in potential voltage and Nd is the mm, active dominant density raised to 1 and W is same like this is the here. These are the equation for capacitance and to calculate the width and capacitance of the avalanche photodiode. Uh, some merits of the Photodiode diode is that the large gain, greater level of sensitivity, and high speed of the operation. These are the merits, and demerits of the Photodiode diode is that the much larger operating voltage required to operate the avalanche photodiode is very high frequency, very high temperature or high current is required to operate on that high voltage. Much higher level of noise. Output is not linear because output is not linear because the whatever the whatever the current or energy comes from or whatever the rays from comes from the solar cell sun from solar cell, this is not constant because they vary, so that's the output is not linear. So if the current is high comes from current is high, then the output is very high. If the current is low and the output is fluctuated, is not linear, that's why the output is non-linear. The required high reverse bias for operation, not as a widely used due to low reliability. They are not using. It's very rarely used for this. Here it is used. I will tell. Level of gain is important for high voltage requirement. Laser range finder, fast receiver model for the data communication. High speed laser scanner, 2D barcode scanner reader are used for avalanche photodiode and high and speed gun. These are the applications of avalanche photodiode. Thank you for watching. If any query regarding to photodiode uh, and tunnel diode, then comment me the question. I will definitely answer you on that comment. So thank you for watching.